On March 26, 2025, OpenAI announced that ChatGPT would natively support the Model Context Protocol. That single decision may matter more than any model release this year, not because of what ChatGPT can do, but because of what it signals. MCP, originally developed by Anthropic and open-sourced in late 2024, just became the de facto standard for how AI systems connect to the outside world. Google's DeepMind followed. So did Microsoft, Amazon, and scores of smaller players. This isn't a model war anymore. It's an infrastructure convergence, and most builders haven't wired it in yet. Here's the core problem MCP solves. Large language models are powerful, but isolated. Every time a developer wants an AI to access a database, call an API, or read a codebase, they build a custom integration, a bespoke connector. One model, one tool, one brittle bridge. Multiply that across thousands of tools and dozens of models, and you get an exponential mess. MCP eliminates that. It's a universal, open protocol. Think of it as USB-C for AI, one standardized interface that lets any model talk to any data source or tool. The spec defines how a client, the AI application, communicates with an MCP server, the thing exposing tools, resources, or context. JSON RPC messages, capability negotiation, structured tool definitions, clean, stateful sessions. When OpenAI adopted MCP, Sam Altman didn't frame it as a concession. He framed it as obvious, and he was right. A new model with better benchmarks captures attention for a week. A universal integration protocol reshapes the entire ecosystem permanently. Before MCP, every AI platform was building its own plugin system. OpenAI had custom GPT actions. Google had extensions. Every startup had proprietary connectors. The result, fragmentation. Developers built once for one platform and started over for the next. MCP collapses that. Build one MCP server and every compliant client, ChatGPT, Claude, open source agents, IDE copilots, can use it immediately. Mahesh Murag, who leads MCP efforts at Anthropic, described the vision plainly. We want to build the best protocol, not the best proprietary lock-in. That's the shift. Interoperability 1. The practical accelerant here is the MCP Apps SDK, which has rapidly become the default integration layer for cross-platform AI context. It abstracts the protocol's complexity, transport negotiation, session lifecycle, capability discovery, into straightforward developer interfaces. Python, TypeScript, both well supported. What this means concretely, a developer building an AI-native application no longer chooses between ecosystems. They build against MCP, and their app works everywhere the protocol is spoken. The SDK handles local STIO connections for desktop tools and remote streamable HTTP for cloud deployments. One codebase, universal reach. Now 3 MCP server patterns have emerged that every AI-native builder needs to understand. The first, memory servers.
These are shared long-term memory vaults that give AI systems persistent context across sessions. Without memory, every conversation starts from zero. Memory MCP servers solve this by storing structured knowledge, user preferences, project context, prior decisions, and exposing it through the protocol. Multiple agents can read from and write to the same vault. The open-source ecosystem has moved fast here. Servers like MCP Memory implement entity relationship knowledge graphs that any MCP client can query. This is how AI goes from stateless tool to genuine collaborator. The second pattern, delegation servers. These are specialized MCP servers that act as expert subagents. A primary AI delegates specific tasks, codebase analysis, security auditing, test generation, to purpose-built servers that return structured results. This is where the architecture gets powerful. A coding assistant doesn't need to understand every language and framework internally. It delegates to a codebase analysis MCP server that parses repositories, maps dependencies, and returns architectural summaries. The orchestrating agent stays focused on the user's intent. The delegate handles the domain expertise. Sentry, JetBrains, SourceGraph, established developer tooling companies have already shipped MCP servers following this pattern. The delegate model turns monolithic AI into modular, composable intelligence. The third pattern, knowledge graph servers. These expose structured, domain-specific knowledge as queryable graphs through MCP. NVIDIA's developer stack is a striking example. Their documentation, CUDA programming guides, GPU architecture references, and optimization strategies all exposed as an interconnected knowledge graph that any MCP-compliant AI can traverse. This isn't simple RAG, retrieval augmented generation, where you vector search chunks of text. This is structured relational knowledge with typed edges and semantic context. When an AI agent queries an MCP knowledge graph server, it gets not just answers, but relationships, not just documents, but understanding of how concepts connect. The pattern generalizes. Legal corpora, medical literature, financial regulations, any domain with complex, interrelated knowledge benefits from this architecture. The numbers tell the story. As of mid-2025, thousands of MCP servers are publicly available. The official MCP server registry catalogs integrations spanning databases, developer tools, communication platforms, cloud infrastructure, and specialized knowledge domains. Cloudflare launched remote MCP server hosting. Composio, Zapier, and Toolhouse built MCP-based tool aggregation platforms. GitHub, Slack, Postgres, Google Drive, all accessible through community or official MCP servers. The ecosystem is growing faster than any AI integration layer before it. And critically, it's open. No single company controls the registry. The specification lives on GitHub under an open governance model.
Anthropic started it, but the community owns it now. If you're building AI-native applications and you haven't integrated MCP yet, the window of optional is closing. This protocol is becoming the expected interface. The three patterns, memory for persistence, delegation for modularity, knowledge graphs for structured domain expertise, aren't theoretical. They're shipping in production systems right now. The builders who move first will have composable, model-agnostic architectures, while competitors are still maintaining brittle, platform-locked integrations. MCP didn't just cross a tipping point. It established the foundation layer for how AI systems will interact with the world's tools and knowledge for years to come. The model wars made headlines. The protocol war just ended quietly, and the protocol won.